Hey everyone, this is the Math Nexus, and today we are going to continue with exercise 3.3. We are actually going to start with this exercise, and this exercise brings with it a new concept. And that concept is called surds. So, what are surds? Yeah, you may know surds as something called under root. For example, we have under root 3, we call this under root a surd. So anything which is trapped in an under root, may it be n, may it be under root a, may it be under root c, it's a surd. Okay, so that's the basic definition of a surd. So basically, whenever you see an under root, we directly know that this is raised to the power 1 upon 2. Now, if we see a cube root, we directly say this is n raised to the power 1 over 3. So we get the concept that whatever number or integer value or any other value is written with the root, the reciprocal of that value is actually the power of the value in it. And as we go through advanced levels, we understand how we can use indices and surds in a mixed plate to find out the actual power. For example, let me just give you a breakthrough. We have something like this and n cube inside. Now, the thing is that we already know that n raised to power 3 is going to come as it is because it's n cube. And as there is as we have discussed, any number with the root, the reciprocal of that value will be the power of n. So basically what we do is multiply that value, 3 multiplied by 1 over 5. And the same thing is happening here because this is n raised to power 1 inside, and then we are multiplying the reciprocal of that value to get n raised to the power 1 over 5. And the same things happen here. And in the resultant, we get n raised to the power 3 over 5. So that's basically how we discuss surds. Another concept I think you should know is whenever we are adding, and I'll get to it in more detail as we solve our questions. Whenever we have something like this, plus 3 under root 6 plus 2 under root 6 under root 6. Okay, so whatever value of the surd is the same inside the surd, we can add them up. For example, 4 under root 5 and 2 under root 5 can be added because the value of the surd is the same. However, we cannot add 4 under root 5 plus 3 under root 6. That would be an incorrect answer. For example, some students do this 4 plus 3 under root 5 plus 6. So this would have been completely wrong. Okay, try to understand this because they're completely different things. It's not a rule in mathematics. So basically, what we do is to solve these type of questions. Getting messy, I know. To solve these type of questions, we just simply do 4 under root 5, bring the values with the same surds together, plus 2 under root 5, plus 3 under root 6, plus 3 under root 6. And now basically what you do, sorry, plus 6 under root 6. Basically what you do now is just add up the integer values. So 4 plus 2 is equals to 6 under root 5. Basically what's happening here is we are taking this under root 5 as the common and then adding the values with it. So it's 4 plus 2 and that would give us 6 under root 5. So basically that's what's happening here. That's what's happening here. So the thing is that try to understand these rules so that you can easily solve any questions. Now people make really silly mistakes regarding these type of questions, and for that the only thing I can tell you is practice a lot because practice makes your math perfect. Okay, so just let me clear this page up and let me proceed on to solving the questions. That's the basic concept you may need for now. And let's jump straight in to question number one. Hey, my thing is the basic concept. You need to solve these questions. I've already given you. We are just going to go through these questions, and if there will be something like different or something more harder, I'll explain it in more detail. However, the questions which are really simple, I'll just go through them. Not much of advanced knowledge here. Okay, so let's go and start with exercise 3.3. So this is 3 under root 5 plus 7 under root 5. Now, again, as we discussed in the intro, that basically what we do is take under root 5 as the common and 3 plus 7. And we get 10 under root 5. Okay, the thing is, however, it's not essential to show this step. Not essential. What I would recommend, and many people would prefer also, is just directly say that this is equals to 10 under root 5. Because basically we add up these index values 3 plus 7 and just directly write the third value. Okay, so just keep that in mind. This step I just showed you to clarify your concept that how we are actually doing this. So not much of a big deal here. So let's go on forward. You just remember you can write this because it's the same thing as 3x plus 4x. We don't always show that x as the common 3 plus 4 here then is equals to 7x. We do not show that. We just simply write this is equals to 7x. And that is also correct. Okay, so just keep that in mind. Okay, for part B. For part B, we have 3 under root 10 plus 2 under root 10. Again, the simple thing, 3 plus 2, what is it equals to 5, and we write under root 10 as it is. Basically, we're doing that because it's multiplying. If it were be adding here, so that would be another case. But right now it's multiplying here. So just simply write it down. Okay, basic questions for part C. Again, basics, 8 under root 11 plus under root 11, and that's obviously going to give us 8. So basically, when there's a single under root 11, what do we assume? It's going to be 1 here, obviously, because 1 under root 11 is actually equals to under root 11. So 9 under root 11, oh, wait a second. 9 under root 11 is going to be our answer for this part. Okay, for part D, we have 6 under root 3 minus under root 3, nothing new, just subtracting it. So 6 minus 1 is equals to 5 under root 3. And that's it. Okay, for question number 2, part A. So basically in question number 2, they have given us 3 statements. 3 under root 5 plus 7 under root 3. Second statement is 2 under root 5 minus 3 under root 3. And the third statement is 2 under root 3 minus under root 5. Now they have told us some options what we are going to do regarding the statements. So just directly write them down. So what is A plus B? A plus B. We have to find A plus B. Really simple question, not big of a deal. Just first of all copy down A. Okay, 3 under root 5 plus 7 under root 3. Plus just copy down B, 2 under root 5 minus 3 under root 3. Simplify the brackets, we get 3 under root 5 plus 7 under root 3 plus 2 under root 5 minus 3 under root 3. Now, as we discussed in the intro, we have to couple up the values of the surds which are the same. So 3 under root 5 plus 2 under root 5, we are just rearranging the equation in this step. Plus 7 under root 3 minus 3 under root 3. So rearranging the equation right now. Okay, so we have got 5 under root 5 plus 7 minus 3 is 4 under root 3. And that's the most simplest answer we can get out of this. So that is actually the correct answer for question number 2, part A. and that's it. Because the thing is, when you have got different certs, we are not going to add them further. That's the simplest form you can get this answer to. However, if this would have been a something like a squared value, we could have done it simpler, but right now it's not the case. As you can see, 5 is a prime number, so we have got easy peasy. Let's just clear this down for question number 2, part B, C, and D. Okay. For part B, they have told us to find out what A minus C is. So basically, we're just going to again copy down A as it is 3 under root 5 plus 7 under root 3. I would prefer you put it in brackets. Sometimes it may come in handy. So minus 2 under root, oh, sorry, 2 under root 3 minus under root 5. And again, as I told you, it comes in handy. Simplify the brackets, 3 under root 5 plus 7 under root 3 minus 2 under root 3, but this is going to be a positive under root 5. Why? Because this negative is going to multiply by 2 under root 3 and also by negative under root 5, which will give out positive 5. Sorry, positive under root 5. My bad. Now, again, rearrange the equation to what makes it simple. Plus under root 5 plus 7 under root 3 minus 2 under root 3. And that would ultimately give us 4 under root 5 because it's essentially 1 under root 5 here. Plus 7 minus 2 is 5 under root 3. And that's it. This is the answer for part B. 4 under root 5 plus 5 under root 3. Okay. For part C, they have told us to find out 2A plus 3B. Now, this is where things get a little bit more complicated. I'll continue here. So 2 multiplied by A. Now, copy down the A statement. 3 under root 5 plus 7 under root 3 plus 3 multiplied by write down the B statement. 2 under root 5 minus 3 under root 3. Now simplify this statement. We get 3 2 is 6 under root 5 plus 7 2 is 14 under root 3 plus 3 2 is 6 under root 5. Minus 3 3 is 9 under root 3. Now again, most students do the mistake that they multiply this 2 by 3 and also by 2 under root 5. I don't know why they do it, but the only requirement is to multiply by the index value. Okay, so just multiply this by, if you're multiplying 2 multiplied by 3 under root 5, we just simply multiply the both index values, which will give us 6 under root 5. Okay, so just keep that in mind, that don't interfere with the surd if in that case. Okay, so just simply do that and then rearrange the value, the equation, so that you can get the same surds on the same side. 14 under root 3 minus 9 under root 3. Now, as you can do, 6 plus 6 is 12 under root 5 plus what is 14 minus 9? It's equals to 5. And 5 under root 3. And that's our answer for part C. Okay, so for part D, what we are going to do is write down what they've asked again, simple things, 5A plus 2B minus C. Now they've just bumped up the complexity a little bit, not too much. So we'll just first of all do the same thing we have been doing before. 5 multiply, write the statement of A, 3 under root 5 plus 7 under root 3. 3 under root 5 plus 7 under root 3. Plus 2 multiplied by, what is the B statement? 2 under root 5 minus 3 under root 3. Minus, now copy down the C statement, 2 under root 3 minus under root 5. Okay. Now simplify this statement. 5 3 is 15 under root 5 Wait a second. Let me just. All right. Now 15 under root 5 plus 7 5 is 35 under root 3 plus 2 multiplied by 2 under root 5. So this is going to be 4 under root 5 minus, because 2 multiplied by 3. So minus 6 under root 3 minus 2 under root 3. And this will be positive under root 5. Again, really essential to write everything in a bracket before you add up, because it's basically multiplying everywhere. So the negative sign will multiplied by negative under root 5 will give us positive under root 5. So basically now just simplify this 15 under root 5. I'm going to rearrange the equation so to bring the surds back into place. Plus 4 under root 5 plus under root 5 plus 35 under root 3 plus 4 under, minus 6 under root 3 minus 2 under root 3. Okay. Now, the next thing we are going to do is simply just add them up and subtract them up, whatever we require here. So basically 15 plus 4 is 19. 19 plus 1 is 20 under root 5 plus 35 minus 6 is 29. 29 minus 2 is 27. So 27 under root 3. And that's it. This is our answer for part D, question number 2. Not much of a advanced or super hard question. Just simple questions here. Okay, so proceeding on to question number 3. For question number 3, now they're kind of getting a little bit advanced, but not as much. Okay, so try to understand the sequence. So they've given us a sequence. They've told us the first four terms of a sequence are 2 plus 3 under root 7, 2 plus 5 under root 7, 2 plus 7 under root 7, and 2 plus 9 under root 7, and on and on and on. So we could have applied the formula of arithmetic and geometric series. We're going to that chapter later on. I don't know, it's chapter 11 or it's chapter 10. It's the series chapter. So it's basically the arithmetic and geometric progression. We could apply it here, but right now, just to clarify your concept and just to go according to the book, we are not going to assume that you know that concept. So right now, we just do as it is. So we just use our mental math right now. So they have told us to write down the sixth term of the sequence. Now the thing is, you understand what is 2 plus 3 under root 7. And then it comes 2 plus 5 under root 7. Then it goes on to give 2 plus 7 under root 7. And then 2 plus 9 under root 7. Okay. Now the thing is, when you write down, you notice that the index term, the term with no surd, is the same. So we can say that some value related to under root 7 is being added. Now we see a common factor here, 3 under root 7, then 5 under root 7. That means this is a plus 2 under root 7 in these two terms. Then we go on to say 2 plus 7 under root 7 and 2 plus 9 under root 7. What's the common, what's being added? 2 under root 7, because 7 plus 2 is 9. And then again for the middle part, 5 under root 7 plus 7 under root 7. What's the main difference in this? Because if, how am I finding the main difference, by the way? 2 plus 5 under root 7, and then I subtract it from the previous term. So minus 2 plus 3 under root 7. And then when I subtract it, I basically get the value 2 under root 7. So again, 2 under root 7 is being added in this series. So step by step, as we go throughout the series, we get 2 under root 7. So this is the first term, this is the second term, this is the third term, this is the fourth term, and they've asked us the sixth term. So what would be the fifth term? The fifth term would be 2 plus 9 under root 7 plus 2 under root 7. Simple. So what would it be? 2 plus 11 under root 7. And then, but this is not required. Okay, this is not required right now. What we require right now is the sixth term. So what would be the sixth term? Again, we use the fifth term, 2 plus 11 under root 7 plus 2 under root 7. What would it give us? 2 plus 13 under root 7. And that is our answer. Okay? 2 plus 13 under root 7 would be our answer for question number 3, part A. Okay? Again, if you know arithmetic and geometric progression formulas, you could use it here. Right now, I'm trying to keep it basic, so that's why I'm not using it. Okay, for part B, we have find the sum of the first 5 terms of this sequence. First 5 terms, again, the reason why I directly find out fifth term is because we are going to need it here. So, first 5 terms. So, 2 plus 3 under root 7 plus, the reason why I'm not adding brackets or anything is because there's no subtraction sign. So, there's no complexity here. Just directly add them up. 2 plus 5 under root 7 plus 2 plus 7 under root 7 plus 2 plus 9 under root 7 and plus 2 plus 11 under root 7. These are the first 5 terms. Now just simply add them 2, 2, 2, 2, 2. How many times there are 2? 5 times. So 5 twos is 10. So we are just simply adding them up. Plus, now the thing is 3 plus 2. So sorry, 5 plus 3 is 8. 8 plus 7 is 15. 15 plus 9 is, what is 15 plus 9? It is 20. 15 plus 9 is 24. 15 plus 9 is 24. 24 plus 11 is going to be equals to 35. 35. So this is 10 plus 35 under root 7. Basic mental maths, and your answer is here. That is it for part B. Okay. So for part C, let me just wait a second. Okay, for part C, oops, I want to make my line more better idea. Okay. So part C, what they've told us is write down an expression for the nth term of the sequence. I mean, I've been trying to avoid that formula, but I guess it's still, it's one of the requirement. I don't know why they're adding it here. But the thing is, it's in your syllabus. I was trying to avoid it because it's not part of the chapter, but still, you're going to learn it not now, but later on. So why not now? So one of the formulas for arithmetic series, which is in your syllabus, and it's essential to know that arithmetic progression series. What's arithmetic and geometric progression? So basically, arithmetic progressions means that the same thing is been added. As you can see in this one, 2 plus 3 under root 7, 5 under root 7, 7 under root 7. So all of them, there's only one value being added, 2 under root 7. That's when arithmetic progression comes up. And geometric progression is basically, it's adding first 2 under root 7, then it's adding 4 under root 7, then it's adding 6 under root 7. So it's basically addition of an addition. We'll get to it when we come to that series chapter, but for now, just remember the arithmetic progression, which is the normal progression. The same value is being added. So what's the formula for the arithmetic progression? And that formula comes in the add math formula sheet, okay? So no need to, memorize it. The thing is, the formula is a plus n minus 1d. And what's that formula for? The nth term of the sequence. So basically, what does this formula represent? So a is actually the initial term, and n is obviously the nth term, whatever we want to call it, the sixth term, seventh term, whatever it is given in the question. And D is actually the common difference. And in this case, what is the common difference we have discussed right now? It's 2 under root 7 positive. So in this case, the common difference is 2 under root 7. Okay, just plug in the values. What is the initial term? We know the initial term is the first term. So 2 plus 3 under root 7 is the first term in this sequence. And then we are going to add what? N minus 1d. So basically n minus 1, because they've just asked as the nth term. They've not asked some specific term. For example, in this case, they asked as the sixth term. So for the sixth term, we could have written 6 instead of n here, okay? But right now they've just told us nth term. What is the common difference? 2 under root 7. So basically, we just simplify this 2 plus 3 under root 7 plus 2 under root 7 n. In fact, I would prefer to write it as 2n under root 7 minus 2 under root 7. Now just subtract 3 under root 7 minus 2 under root 7. So we have got 2 plus 2n under root 7 plus under root 7 as 1 is equal to answer. And that would give us what? The nth term of the sequence. That's it. This is it for question number 3, part C. Okay. You could, by the way, write this in this way. I've just simplified it. It's not essential to simplify it, but right now just do it as it is. This both of them can be accepted as answers. Okay, so let me just clear this down for part question number 4. Okay, so question number 4 is a little more easier, I would prefer to say. So right now we can see directly in this question number 4 that this triangle is a right angle triangle. And whenever we have a right angle triangle, we can say that Pythagoras theorem is applicable on it. Is applicable. So if Pythagoras theorem is applicable, so no big deal if you want to find out this AB as required in the question. They've asked us the exact length. And whenever they have given you exact, for example, if you're solving logarithms, log 16 is an exact value. Okay? Oh, sorry, there's nothing like log 16. For example, LG 16 is an exact value. That exact value, LG16, what would be LG16 equals to? Wait, let me tell you. LG16 is equals to something like 1.204119983. As you can see, it's a big value. So if we would write 1.204 just by rounding it off, it would be incorrect if they have asked us the exact value in the question. So when there's an exact value in the question, just directly write the most basic value we can. If we would write the exact value in terms of a decimal, we would have written something like the whole value 1.204119983, and that would be a tedious task. Instead, why not just write LG16? So whenever they ask you the exact value, you write the exact value, not in terms of decimals. Okay. So basically, what we are going to say is the Pythagoras theorem says 7 squared is equals to 4 squared plus x squared, and we are assuming x is equals to AB. And basically, for those of you who do not understand this right now, that this 7 squared is here because it's right opposite to the right angle triangle, 90-degree angle, and obviously these two sides are going to be equal to the hypotenuse. Okay, so 7 squared minus 4 squared is equals to x squared. So what is 7 squared minus 4 squared? It's equals to 33, and 33 is equals to x squared. Under root 33 is equals to x. Now, the exact value of the AB is under root 33 because most students might have written that 5.74456247. They would have written just like 5.7 because they rounded it off. That would not be the exact value. So whenever they ask us for the exact value, just write it in this form, not in the decimal form. Okay, for part B, find the exact perimeter of the triangle. No big deal. Under root 33, we know that's AB plus 7 plus 4 because they've already given us that value. So 7 plus 4 is 11. 11 plus under root 33 would be the exact perimeter of this triangle. And that's it. This was something really basic, not much of a concept in this one. And that's it for question number 4. Okay, so question number 5. The thing is, this one is a challenge question, but to be honest, I'm going to be really honest. There's not much of a concept. It's just basically we have to divide each and every equation, and solve it step by step, and you'll find it easier to solve. So basically, what they've told us, the number of in the rectangle on the side of the triangle is the sum of the numbers at the adjacent vertices. Now, most students actually don't understand what the question is telling you. It's actually telling you that the vertices, which is the points, vertices are actually just small points. So they're telling us that at the adjacent vertices, x and z, this rectangle shows that it is the addition value of it. Okay. Similarly, for y and z, this rectangle is the addition value of it. So basically, we have got three equations to this. We have got x plus y would give us this rectangle value, which would be 13 plus under root 2. Similar, this would be equation 1. Similarly, we would have y plus z is equals to 20 minus 3 under root 2, because y and z would give up this value. This would be equation number 2. And again, the third value is x plus z, x, z and x would be equals to 17 minus 10 under root 2. So as you can see, we have got three equations. And when we have got three equations, what does that mean? We can find out three variables from it. So the most common method I like to solve this with, these type of questions with, when we have three equations, is I try to bring two equations equal to one variable. So right now I'll try to make the most possible equation, in fact two equations, equals to z. So I've got two values for z. Z is equals to 17 minus 10 under root 2 minus x, because this comes here. So this would be equation number 4. Then I would have the second equation for z is 20 minus 3 under root 2 minus y. And that would give us the fifth equation. Now what I'm going to do is put equation 4 and 5 as equals, because this is z and this is z. I have two equal equations. Okay. So we have got two equations in terms of z, and we can say that we can replace the z. So 17 minus 10 under root 2 minus x would be equals to 20 minus 3 under root 2 minus y. I hope it's clear till now. Okay. Now the third step we do is we either find y in terms of x or we find x in terms of y, because we have to remove either one of the variables. Now the thing is, we see that equation 1 is in terms of x and y, both of them. So what I'm going to do is I'm going to basically find out either y in terms of x or x in terms of y. For now, I'm going to choose y in terms of x. So if I were to find y in terms of x, I would say 13 plus under root 2. I would copy equation 1. So this is x plus y. This is equation 1. And I would find out equation number 6 out of this, which would be 13 plus under root 2 minus x. And now I found equation number 6, which is actually what? It's y in terms of x. So I'm going to replace this y value with this value. So which one was this? Sorry, this was some new equation we found out, and now we are going to put in equation number 6 into this. So 17 minus 10 under root 2 minus x is equal to 20 minus 3 under root 2 minus, in a bracket, we're going to write down the value of y, 13 plus under root 2 minus x. Simplify this, I would get 17 minus 10 under root 2 minus x is equal to 20 minus 3 under root 2 minus 13 minus under root 2 plus x. Okay. So the next thing I'm going to do is 17 minus 10 under root 2. Okay. So I'm going to say that first I'm going to simplify this side. I'm going to get 20 minus 13, which is equals to what? 7 minus 4 under root 2 plus x is actually equals to 17 minus 10 under root 2 minus x. I'm going to bring this minus x here actually. I'm going to write plus x here also. So 17 minus 7, that is going to give me 10. Okay, in fact, I'm going to solve it as 17 minus 7. Then I'm going to do minus 10 under root 2 plus 4 under root 2 is equals to 2x. So it's basically equals to 10 minus 10 plus 4 is equals to 6 under root 2 is equals to 2x. So divide by 2, x is equals to 10 minus 6 under root 2 divide by 2. So 2 5s are 10 and 2 3s are 6. So x is equals to 5 minus 3 under root 2. And that is the value of x. Now we have to find out y and z. And now I think I should prefer to solve it in another page. I might need these equations. So I'm going to solve the value for what? First of all, I find out y because that's the most clearest value I can find without having another equation. So I'm going to write down y 13 plus under root 2. Y is equal to 13 plus under root 2 minus x. So basically, I have this value of x. I just found it out. So I'm just going to plug it in here. So y is equal to 13 plus under root 2 minus what is the value of x? 5 minus 3 under root 2. Again, it's essential to add a bracket because this negative sign is going to be multiplied here. 13 plus under root 2 minus 5 plus 3 under root 2. So y is equals to 13 plus 13 minus 5. So 30, what is 13 minus 5? 13 minus 5 is 8. Yes, 8. 8 plus what is 3 plus 1? 4 under root 2. And that's equals to y. Now we have to find out what? Z. We have y in terms of z. Y plus z is equal to 20 minus 3 under root 2. So y plus z is equal to 20 minus 3 under root 2. This is equation 2 or what? Which equation is this? This is equation number 2. So simply just plug in the value of y and we'll find out z. So z is equal to 20 minus 3 under root 2 minus the value of y because this comes here, it's going to be negative. So what is the value of y? We just find out 8 plus 4 under root 2. So z is equal to 20 minus 3 under root 2 minus 8 minus 4 under root 2 because this negative sign is being multiplied here. So we are going to get z is equals to 20 minus 8. What's 20 minus 8? It's equals to 2 I guess. No, it's equals to 12, sorry. So it's minus 3 minus 4. What is 4 plus 3? It's negative 7 under root 2. And that's the value of z. So in fact, that is not the single answer. We have y. In fact, I'm going to pretty print it. What is the value of x? We just found out. It's 5 minus 3 under root 2. What is the value of y? Y is equal to 8 plus 4 under root 2. And what's the value of z? Z is equal to 12 minus 7 under root 2. And these are the three values which have been required by us in question number 5, which is the challenge question. As I told you before starting this question, this is not much of a hard question. But still, people do get confused in these type of questions. Proceeding on to question number 6, and that is a hard question I'm going to tell you. Okay, so the thing is, for question number 6, I had to change my note-taking app. And in fact, this will be my usual note-taking app from now on. And the thing is that the reason why I chose this is because I think it will be much more easier for me to make you understand specifically these type of questions in this one. So the thing is that this challenge question, I mean, it is kind of challenging. I gotta accept this one. So the thing is that what they've told us is this design is made from one blue ball. So we can see that this is one blue ball, one blue circle actually, four orange circles. So there are four circles inside this one blue circle, And in each of these four orange circles, there are four green circles. So a total of 16 green circles. Okay. So what we are going to say, they have told us that all of those circles are touching each other, given that the radius of each green unit is each green circle is 1 unit. Find the exact radius of the orange circle. So first of all, we are only going to focus on what the orange circles. The thing is, if we notice right now, they've told us that the radius for this circle, the half of this circle, is actually what? 1 unit. So the thing is, what can we say that from this point up till this point, won't it be 2 units? Because from the radius of this circle to the radius of this circle, this would make 1 and 1, which would be equals to what? 2 units. Okay. So I hope that's clear till now because we have connected one radius to another. Now the second step is basically, let me just clarify this 2 here. What we have to do now is make this a triangle. So basically, after we have made this one a triangle, we can say that, oops. Now we can say that this one triangle is actually what? It's a right angle triangle because we have made it ourselves. So the thing is that this is equals to 2. Okay, we have discussed this why this is equals to 2. Now the thing is we have to find these two sides, this side and this sides. And the reason why I'm assuming these two sides to be equal. So why are they actually equal? So the thing is that the same proportion of the radius is going through this part and the same proportion of the radius is going through this part. So we do know that our answer is actually greater than what? 1 because it's greater than the radius. Then there's a specific part in this question which is in the middle of this orange circle. So we can say that this part and this part are equal. I don't know if I can highlight it. Wait a second. This part from here to here is equal to this part from here to here. It's a really minor distance, but there is a distance. So what we can say is that if we want to find out, so basically, how are we going to find out the radius of the orange circle? Well, the radius of the orange circle is equals to this part, this whole part, which is the base, plus the radius of the green circle again. So the thing is, if we add these two values individually, we'll get what? We'll get the whole radius of the orange circle. So basically, first of all, our main focus would be to find out this thing. And we've discussed that this and this is equal. Why? Because well, the same part of the radius is following through this, and this part and this small part are equal. So we are going to say that this, well, we are going to use a trigonometric identity. We are going to assume for now that this is equals to x, and again this is equals to x because these two sides are the same. So the thing is now we are going to say x squared plus x squared is equals to what? 2 squared because that's the hypotenuse. So we are going to say that 2x squared is equals to 2 squared. X squared is equals to towards 2 squared, it's equals to 4 divided by 2. So 2 ones are 2 and 2 twos are 4. So x is equals to what? Under root 2. And this is getting a bit messy. It's equals to under root 2. Okay. So now we have the value of x. Now before I proceed on here, let me just divide it up. So we have the value of x, but this is not actually the radius of the orange circle. How did we can figure out we're going to find out the our radius of the orange circle? It's basically this x value plus the radius of the green circle. Then we would get what? The whole radius of the orange circle. So that's what we're going to say. So x squared, in fact, plus radius of green circle will be equals to what? Is equals to the radius of what? The orange circle. Now the next step is we are going to find out what's the x squared we just found out. It's under root 2 plus 1, which would give us the radius of the orange circle. We could just directly, in fact, I would prefer if you directly write the answer as 1 plus under root 2. It can also be written if you want, or if it is required in any type of question, 2.414. That's enough. But the preferable answer is this one. Okay. So this is the answer for what? Part A. Okay. So for part B, let me just make a division here. Okay. So for part B, what we are basically going to do is repeat the same steps. So, and the thing is, before I go forward into making these drawings, we are again going to connect the radius by the radius. So first of all, connect the radius by the radius. And and one essential thing to remember, a second, let me just first complete this drawing. Okay. This is something. This one. The thing is, one essential thing to remember is that the diameter is a superpower, because if you would have made this whole circle like that, I hope it's going to be clear here, then that would have been wrong, really wrong, because we do not know any value we could use. So basically, we are going to use our radius to find out this one. And I'll go on. Again, we'll assume that this one is y, and because of the fact that these two, this one and this one, oops, we made a square. So because of the fact that this one and this one is the same, we're going to assume that both of them are equals to y. So we can say, and what is this equals to? The whole, this thing. What's this equals to? It's equals to the diameter of the orange circle. In the previous part, we found out the radius 1 plus under root 2. However, it's essential to remember we have to find out the diameter, because this is one radius and this is another radius. So what we're going to do is simply multiply this radius of the orange circle 1 plus under root 2 by 2, which would give us the value 2 plus 2 under root 2. Okay. Now that's the first step in solving this question. Now the second thing is we found out the hypotenuse, which is obviously what? 2 plus 2 under root 2. Okay, so that's the value for the hypotenuse. Now we are going to simply solve this up. 2 plus 2 under root 2 whole squared should be equals to what? Y squared plus y squared. Okay, so the next thing we are going to do is we are going to say that a square, we are going to simplify this first of all. Open this bracket up. A squared is 4 plus 2ab. By the way, we are following the formula a squared plus 2ab plus b squared. This is the identity. I hope you know that. So a squared is equals to 4 plus 2. A is 2 again. B is 2 under root 2. Plus, what is b squared? It's 2 squared 4 multiplied by under root 2 is equals to 2y squared. Okay, so the next thing we are going to do is simplify this. 4 2s is 8 and 4. 8 plus 4 is 12 plus 2 to the 4, 4 2s are 8 under root 2 is equals to 2y squared. And y squared is equals to 12 plus 8 under root 2 divided by 2 will give us 6 plus 4 under root 2. Okay. Now the thing is, we say that y is equals to the under root of 6 plus 4 under root 2. Now, it may seem a little bit complex and intimidating, but thing is, you should know the method of how to do this. So the thing is, we have 6 plus 4 under root 2. How can we simplify this inside and under root? So the basic form to solve these type of questions is, first of all, understand the factors. Now the thing is, how can we take this out? We have to first make it a complete form. And when I mean a complete form, I mean like this. Wait a second. So if I have an under root, um, if I would get something like a plus b whole squared, I could easily get my answer, which would be a plus b, because thing is, this under root will be cancelled by the squared value. So in order to find this a plus b whole squared, what would I need? So if I can say any equation can be given the form a plus b whole squared. So if I were to open this a plus b whole squared, I would get a squared plus 2ab plus b squared. Okay. So the thing is, what we do next is we compare our current equation with what? A squared plus 2ab plus b squared. Okay. Now this is a method to solve under roots. Remember that. Um, so if I would be able to get this equation of mine into this form, I would be able to get what? I will be able to simply cut down the under root by the squared value, which that equation gives me. Okay. So the basic thing I'm going to do is try. So the thing is, we assume that 2ab is going to give us 4 under root 2. That's the first step you do. Okay. We say that 2ab will be the under root value. So 2ab is equals to 4 under root 2. And specifically, the b value is what? It is the um, under root value. Okay. So we first of all assume what, that the 2ab is equals to the whole under root thing, and we assume that b itself is under root 2. Now I know this may sound a bit confusing and all, but the important thing to realize is that we consider the values according to ourselves. So b will be the third value always. So for example, if we would have uh, okay, I will explain it later, by the way. So now we are left with 2a, which is equals to what? 4, because 2ab is 4 under root 2 and b is under root 2, so 2a is left with 4, and a is equals to 4 divided by 2, which is equals to what? 2. Before we go on, okay, so we have got the values of a is equals to 2 and b is equals to what? Under root 2. Okay. And before we proceed on, a tip to check if you are doing it correctly is we find out a squared. What is a squared? It's equals to 4. And what is b squared? B squared is equals to 2. So the addition of these two values should be equal to what? The integer or constant value. So as in fact the integer value. So 4 plus 2 is equals to 6, which gives us this 6, which means we are going on the right base for this question. So we have got A and we have got B from the following solution we have done here. Okay. So we've got A and B. We can say simply, okay, in fact, I need some more space. So we are going to, before I do that, let me just take this up here. In fact, I'm going to move it right now here. Okay. So this is how we find out A and B. Okay. So this is how we find A and B out. Okay. Now the next thing we are going to do is we have A and B, and we say that y is equals to under root of, I don't know why it's so squiggly. So y is equals to under root of what? We have to give, and now we have the A and B. Now what we are going to write it out? A plus B, if a whole squared. Okay, because we have the a and b values out of this equation, we are just simply going to write an a and b. By the way, if this would have been negative 2ab in any case, then you would have replaced a plus b by a minus b. Okay, just to clarify. So what is a? The value of a here? The value of a is 2. And what's the value of b? The value of b is under root 2. And that whole squared. Now the thing is, we are easily going to cut our square value from this, and we would get y is equals to 2 plus under root 2. Now the radius of the blue circle, however, is not equals to 1. The radius of the blue circle is equals to what? It's equals to the y value plus the radius of the orange circle again. So that's what we are going to do again. So radius of the y value, first of all, 2 plus under root 2, plus the radius of the orange circle, which is 1 plus 2 under root 2. Sorry, under root 2. 1 plus under root 2 is equals to radius of blue. Okay. Now the next thing we are going to do is just simplify this. 2 plus 1 is equals to 3. Under root 2 plus under root 2 will give us what? 2 under root 2. And that is our answer for part B. Okay, 3 plus 2 under root 2 is our answer for part B. And that's it. That is the radius of the blue circle. And that is for the question number 6, which is the challenge question. Um, I mean, it's honest review. It does have a lot of hard concept. I mean, yeah, look at the under root 6 plus 4 under root 2. It's a bit of a hard concept. I'm going to admit that. And this one was actually what I would consider a hard question. So that's it for question number 6. I'll meet you in the next lecture with the rest of exercise 3 point. I don't know what we are solving, but I'll meet you in the next lecture with whatever exercise comes after this. Thank you. See you next time.